We are going to talk about variation with regard to your x and y variables. This will be next for IP 1.13. We'll start off with direct variation. Y is going to vary directly as x, meaning that they are directly proportional. As the y variable increases or goes up, the x variable is going to increase or grow. As the y variable goes down, the x variable is going to be also doing the same thing. The equation that we use for direct variation is y equals k times x, where the value k is equal to either constant of proportionality. So we're dealing with proportions sometimes. Then we have inverse variation. Y varies inversely as x. Y is inversely proportional to x. Therefore, as the y variable were to go up, then the x variable is going to go down, and we have vice versa. As the y variable goes down, then the x variable is going to go up. Our equation for y is that we have a fraction this time, k over x. That'll be inverse variation. We'll get to some examples a little later. Thirdly, we have joint variation. We've got joint variation. Z varies directly with x and y, jointly proportional to x and y. And our equation is that z is going to equal k multiplied with the variable x multiplied with the variable y. And fourthly, we have the nth power, where y varies directly with the nth power of x. And our equation will be as follows: y equals k, we are constant of proportionality, multiplied with x raised to the power of n. Now it's time for our examples. This will be the first example. We'll have 4 total. Our directions here are: if y varies directly as x and the y value is 6 when x is 4, we need to find the value of k. Reminder for direct variation, so we're varying directly, then our equation is y equals k times x. Therefore, I know the y value is 6. I do not know the value of k, but I do know the value of x is 4. So I'm going to solve for the k value. Dividing by 4 results in the fraction 6 over 4. Then I'm going to have to reduce that. So y equals 3 over 2. And once we've gone to that point, then we can actually write the equation. And that's what we're looking for as far as the answer, with the value of k placed into the equation. So y equals 3/2 multiplied by x. The second part of that same particular problem, now that we have an equation, y equals 3/2 times x, we want to find the y value when x is 20. We're just going to plug in the value of 20 in place of the x. So we have y equals 3/2 times 20. Once you have the fraction, it's 20 over 1. We can do some cross canceling if you choose. We'll do 2 and the 20 can cancel out. 2 becomes a 1, 20 becomes a 10. And then we just need to multiply and get the value of y is equal to 30. Moving on to example number 2, where we're going to deal with inverse variation. If y varies inversely as x, and y is 4, and x is 16, We want to find y when x equals 10 is our task. But we're still going to need to, before we can figure out what the y value is, we're going to need to figure out the value of k first. Now remember, with inversely proportional, our equation is that y equals k over x. We are given that the value of y is 4, the value of x is 16, so I'm going to replace those variables with those values. So 4 equals k over 16. I need to solve for the k variable. The k is connected to 16 by division, so to undo division and multiply on both sides. That's what you do to one side, you must do to the other side. 16 times 4 is 64. Over here, my k is going to be left by itself because the 16s are going to cancel. And so I have k equals 64. Therefore, the y value is what we're looking for, and I know that the value of x is 10. I'll go back to my equation that we just found out. Y equals k is 64 over x. Now I'm going to use substitution to figure out what the y value is. Y equals 64 over 10. And then when I divide by 10, I can just move the decimal point. And y equals 6.4. In example number 3, we're going to look at joint variation. So if z varies jointly as x, then you can read the rest of it here. We've got z is 10, x is 4, y is 15. We're at the very end of this example supposed to find the value of z, and we're given values of x and y. Before we can find the value of z, when we have the equation for joint variation, we know that z equals k multiplied by x multiplied by y. We need to find the value of k first. We're given that the value of z is 10, so we'll substitute that in. We don't know the value of k. My value of x is 4. The value of y is 15. And so we're going to need to solve for k. 4 times 15 is 60. So we get 60k. And then we're going to divide both sides by 60 to solve for k. And we get k after reducing because both those end in 0, so we cancel it out. We get k to 1, 6. Now that I know the k value, I can find my value for z, knowing that I have z equals 1, 6 on this formula right over here, multiplied by x, multiplied by y. I now know that when we're trying to find z, the x value is 12, and y value is 7, therefore z equals 1/6 using the value of substitution. 12 in place of the x, and 7 in place of the variable y. 12 times 1/6, 12 as a fraction is 12 over 1, so it's really 12 divided by 6 is 2, and then 2 times 7 is going to be 14. So z is going to equal 14. Will be the answer there for z. And then last but not least, we're going to look at directly proportional to the nth power. So y is directly proportional to the third power of x. And you've got the details here about y and x, and eventually we're supposed to find the y value when x is equal to 8. The equation that we must use at first here is that y equals the value of k times x, and then the power that we're looking at is the third power, so it's the third. We are given the value of y is 750 equals, I need to find the k value. When my value of x is equal to 10, that's the third power. Taking the third power is 1,000. 750 equals 1,000k. Dividing by 1,000 on both sides, which either one side and the other side. Dividing by k equals. And then here, both these end in 0, so we cancel those out. 75 over 100. Is a reducible fraction to 3/4. Therefore, my equation in the nth power proportionality is that y equals 3/4 or 3/4. multiplied by x, where the x is raised to the third power. And now I'm going to be able to find the value of y when x is equal to 8 by substitution. So this will be the second thing that you would want to do. So part B here is to find y. And the equation that we just found out here, we place the x variable within 8. We're going to cube that. When you cube 8, you're going to get 512. So if you haven't worked on your perfect squares and perfect cubes, then you are going to want to brush up on those. 8 cubed, like I said, is 512. And then we can reduce, because 512 over 1, reduce that, or you can multiply straight across and get a big number and divide by 4. Either way that you want to do it. But once we do the reduction, 512 divided by 4, and then multiply that by 3. So 512 divided by 4 would be the value multiplied by 3, we get 384 for our result for y. So now you have 4 different examples of the 4 different types of variation. The assignment will be given to you. Good luck and have fun.